Welcome back, everyone, to another explainer. All right, let's just dive straight in today because we are looking at some truly staggering numbers defining what we are now calling the 2026 AI super bubble. We're going to explore how highly efficient open weight models are completely upending the industry as we know it. We are literally standing at this fascinating crossroads where massive Wall Street hype is colliding head-on with some very cold, hard engineering realities. And the fallout from this? Well, it's reshaping how every major corporation on Earth is going to deploy AI. We have a seriously packed agenda today. We'll be covering the trillion-dollar disconnect, export bans and geopolitics, the open weight price shock, benchmarking GLM 5.2, scaffolding over raw power, and finally, surviving the AI bubble.
All right, part one, the trillion-dollar disconnect, measuring the AI infrastructure sprint. Let's get into it.
$690 billion. Just let that sink in for a second. This number represents the projected aggregate capital expenditure by the 5 largest U.S. cloud and AI infrastructure providers in 2026 alone. We're talking about nearly $700 billion being poured into data centers, networking infrastructure, and silicon in a single year, driven by tech giants like Microsoft, Amazon, Alphabet, Meta, and Oracle. It is without a doubt an infrastructure sprint of historic proportions, and it's all fueled by this underlying belief that AI workloads are simply going to consume absolutely every available unit of computing capacity we can build. But here is where the math gets, well, kind of terrifying for investors. We call this the deployment gap. You see, hyperscalers are spending hundreds of billions on infrastructure, while the pure-play AI vendors actually utilizing it are generating just a tiny fraction of that in revenue. For instance, Amazon is projected to spend roughly $200 billion on CapEx. Microsoft is tracking toward $120 billion. Yet the leading AI vendors, the very companies driving all this demand, are pulling in comparatively modest numbers. I mean, OpenAI is sitting at an impressive but completely dwarfed $20 billion in annual recurring revenue. Anthropic is at a $9 billion run rate. The math shows this glaring, almost absurd disparity between what is being spent to build the AI ecosystem and what that ecosystem is currently able to earn back.
Honestly, the writing is on the wall here. Major financial institutions like the Bank of England and the IMF are actively warning that this massive disconnect between spending and profit is completely unsustainable. And we already saw this reality culminate in that devastating 10% plunge of the Kospi index back in June of 2026. Savvy investors are waking up to the fact that mega-cap tech firms are taking on massive debt to fund these build-outs. If the revenue from actual real-world AI adoption doesn't catch up, and catch up fast, this structural instability could trigger a severe global market correction. Which brings us to Section 2, export bans and geopolitics, and specifically, the unintended consequences of chip controls. Looking back at 2025, U.S. export policies were shifting incredibly rapidly. It was a wild year. First, they banned specific chips like the NVIDIA H20. Then, eventually they pivoted to allowing the H200 exports, basically in an attempt to keep Chinese labs dependent on American hardware ecosystems. But by the time they finally allowed those H200 exports in December, Chinese authorities actually pushed a boycott. So what was the unintended consequence of all this geopolitical friction? Well, instead of being stifled and cut off, Chinese labs like DeepSeek were forced to get incredibly smart. Since they couldn't rely on unlimited top-tier chips and brute compute force, they had to relentlessly innovate on model architecture and efficiency instead. So what did that forced architectural innovation overseas lead to? Section 3, the open weight price shock, or as it's known in the industry, the tokenomics war. Just look at this stark contrast in pricing. It is wild. Open-weight Chinese models are actively commoditizing AI inference right now. They're offering highly competitive capabilities at sometimes 27 times cheaper than Western proprietary models. How? Because labs like DeepSeek and Alibaba heavily optimized their architectures. They leaned into techniques like mixture of experts. Basically, instead of firing up the entire AI brain for every single prompt, it only wakes up the specific, specialized parts needed for that exact task. Because of that, their token costs have absolutely plummeted. We're talking pennies per million tokens for open-weight models, compared to anywhere from $4 to $15 per million for US proprietary models like OpenAI's own one. For a massive enterprise trying to scale AI across tens of thousands of employees, this price difference isn't just a rounding error. It literally demands a completely different business model. So you really have to ask yourself, how on earth do you justify a $1 trillion valuation when your core product is being rapidly commoditized? This poses a massive existential problem for companies like OpenAI and Anthropic. They absolutely need high-margin API revenues to justify their astronomical IPO valuations. But if highly capable open-weight models are nearly free to run, why would corporate decision-makers overlock themselves into expensive closed-source subscriptions? The core product of the AI boom is effectively becoming a utility, much like water or electricity. Let's look at some hard proof. Section 4. Benchmarking GLM 5.2, OpenWeight versus Frontier AI. The benchmark data here is absolutely undeniable. Let's compare Z.AI's new OpenWeight model, GLM 5.2, against Anthropic's closed-source titan, Claude Opus 4.8. GLM 5.2 offers a massive 1.05 million token context window and incredibly competitive coding scores for a fraction of Claude's price. At under $1 per million input tokens, GLM 5.2 scored a 62.1 on SW Bench Pro. And for those who don't know, that's the industry's gold standard test for autonomous software engineering. So it is trailing the absolute top, most expensive closed models by only single-digit percentages. Yet it offers the massive structural benefit of being open-weight, meaning enterprises can run it securely entirely inside their own private corporate environments. And, the disruption goes way beyond just basic coding. Check out this independent cyber benchmark by SumGrup. They tested models on finding complex software vulnerabilities, specifically IDOR, which are nasty flaws that let attackers access sensitive data they shouldn't. When given a bare raw prompt, the OpenWeight GLM 5.2 model actually outperformed Claude Code. GLM 5.2 hit a 39% accuracy rate, beating both Claude Code Opus 4.6 and 4.8. Think about that for a second. An open-weight model outperforming an incredibly expensive frontier coding agent on a complex, reasoning-heavy security task. That was a massive shock to the entire system. 17 cents. GLM 5.2 achieved that superior security reasoning at an astonishingly low cost of just 17 cents per vulnerability found. This proves, definitively, that expensive frontier models are no longer the default winners by default. When your security team is scanning thousands of endpoints across a sprawling enterprise network, per-bug economics are the deciding factor. You simply cannot afford to pay premium token prices for commodity AI tasks when options like this exist on the market. But there's a really vital lesson buried in that SumGrup data. Section 5, scaffolding over raw power, and why implementation matters way more than the model itself. So, what do we mean by a harness, or scaffolding? It's basically the structural wrapper that feeds an AI model its context, decides exactly what code or data it's allowed to see, and systematically loops it through a designated task. In that same SumGrup test, when they wrapped the AI in a purpose-built custom harness that automatically enumerated endpoints and directed the AI exactly where to look, detection scores skyrocketed up to 61%. This proves that how an AI is integrated is far, far more valuable than simply buying access to the most expensive model. The takeaway for your business is incredibly clear. Buying the smartest foundational model on the market is literally like hiring a genius, but refusing to give them any instructions. You get vastly higher returns by investing your capital in the engineering wrapper that tells the AI exactly what to do. Because without that proper scaffolding, executives face a massive deployment gap. Take a look at this breakdown of 1 hour of AI usage. For every hour an employee uses AI, about 43 minutes are lost to what organizational theorists call productivity leakage. You're only actually saving about 17 minutes of real work. This is the AI productivity paradox in a nutshell. Executives are paying for these tools expecting massive sweeping output gains, but the reality for the boots on the ground is entirely different. So why does this leakage happen? Well, time saved on drafting is almost instantly lost to hallucination checking and corporate bureaucracy, completely wiping out your expected ROI. Let's say an analyst uses AI to write a quarterly report in 2 hours instead of their usual 8. Amazing, right? But if they then have to spend the next 3 hours manually fact-checking the AI's hallucinations, and then that report still sits in a legacy corporate approval queue for 3 weeks, your firm doesn't actually move any faster. Without systemic scaffolding that fundamentally re-engineers the whole corporate workflow, AI is really just a shiny toy that doesn't actually hit the bottom line. Okay, let's wrap this up. Section 6, Surviving the AI Bubble. Actionable strategies for corporate decision-makers. Here is exactly how executives can mitigate the massive risks of overvaluation by focusing heavily on efficiency, architecture, and localized integration. You have to decouple your firm from the AI bubble. First, stop paying for absolute frontier intelligence if a cheaper, open-weight alternative like GLM 5.2 can do the exact same job. Put your budget into building those custom harnesses we talked about, the ones that actually integrate these models seamlessly into your specific business processes.
And finally, considering the totally erratic nature of global chip exports, you need to explore self-hosting these open-weight models to protect your company from sudden geopolitical supply chain shocks. I want to leave you with this provocative thought to consider regarding your own infrastructure investments. Are you strategically deploying an AI utility, or are you just blindly funding an AI bubble? Because the companies that survive the 2026 market correction won't be the ones that bought the most expensive AI. They'll be the ones that deployed it the most efficiently. Thanks for joining me on this explainer, and keep exploring.